Okay. So there we go. So this paper is co-authored with my serial co-author Nabashraf, and with two PhD students, Virginia Minik, who's at the LSE, and Victor Quintas Martinez, who's now at MIT. So the starting point for this paper is a quote from Sir Arthur Lewis' paper, Development with Unlimited Supplies of Labor, which, if you're interested in development, I think contains 90% of what you need to know. It's just that each sentence is a paper on its own. And this is the sentence that I picked for today, which is one of the surest ways to increase national income is to create employment for women outside of the home. That Arthur Lewis wrote in 1954. We are now in 2021, almost 22. And if we look at labor force participation data, there's not much equality. So from 1954 till now, things haven't improved much. Most countries are far from gender parity in the allocation of work inside and outside the home. There's a lot of advocacy, if not policy necessarily, to address this on equity grounds. Okay? So without dismissing the importance of the equity argument for this, there might also be an efficiency argument, which is what Sir Arthur Lewis was pointing out. So low female labor force participation might be symptomatic of misallocation. And there is a recent paper by also Chang Tai-Hsieh and co-authors who calibrate a model of the US economy and estimate that roughly a quarter of all economic growth between 1960 and 2000 was due to a better allocation of talent of women and minorities, ethnic minorities, especially Black. Okay, so this is going to click every time I do it. Maybe likes it a lot, yes. So is this actually the case? Is it a matter of will national income go up if more women join the labor force? But that fundamentally depends on whether the returns to women's talent are higher in work outside relative to work inside the home. Both will produce observationally equivalent levels of female labor force participation, but the type of women who we observe at work and the reason for why they work will be very different. If returns are higher outside the home, what we'll observe is positive selection, which means that women with higher talent will be more likely to work. And in countries where the female labor force participation is lower, the average talent of women in the workplace will be higher because the bar is higher and hence only more talented women would pass it. In this case, we are in the Arthur Lewis world where increasing female labor force participation can increase equity and efficiency. If, however, returns are higher at home, which could be, you could imagine a story by which, centuries of specialization have made women better at home, that will create a negative selection. So the only women we observe at work are those who need to, and therefore increasing female labor force participation will not do much for equity and efficiency. Now, because these two explanations are observationally equivalent, it's hard to say which one plays a role unless you observe variation in these barriers that women face and observe how the ability or the talent of women at work changes when you observe variation. That's what we do in this paper. We have personnel data from a large multinational enterprise that hires about 100,000 people across 100 countries and 4 age cohorts. And we use this to sign selection. Right? The intuition comes from a paper by Claudio Olivetti and Barbara Petrongolo, now many years ago. The intuition is that the correlation between the pay gap and the labor force participation tells us something about the type of women who are in the labor force. In particular, if in countries where labor force participation is very low, the pay gap is small or even inverted, that is, women are paid more, then selection is positive. That is, only the women with higher ability are in the labor force. So we will adapt that test to our microdata. So we will use female labor force participation at the country level and see how that affects the pay inside the firm. And then once we put a sign to selection, we will estimate a model of the firm pay policy, which will allow us to back out the ability distribution and then evaluate policy counterfactuals, such as eliminating gender norms. Okay? We will also, as a verification of the data, use data from other firms in the same country to see whether the misallocation of talent, which we've estimated with our multinational data, predict the productivity of other firms. So that is the plan for the talk. And let's see how much I can cover. So people, the actors in our paper. These are employees for the multinational. We have data on the universe of white-collar regular employee. We only look at white-collar employees because the multinational is a consumer goods producer, and they have manufacturing operations in a subset of the countries. So whereas they have normal marketing and management operations in all the countries where they operate. So we only have blue collars in a subset of countries, and we have white collars everywhere. Now, they're quite homogeneous because the standard educational requirement for getting these jobs is the same everywhere around the world. They all need a college degree, and the vast majority of them have a degree in either business or engineering. It's like 50% business, 20% engineering, and the remaining 30% is more or less variation on the theme. Typical jobs involve things like sales, product development, marketing, and just general managerial activities. And we have data for 4 years, 2015 to 2019. To give you a sense of where, no, sorry, that didn't work. I didn't mean to do that. I didn't mean to do that either. Sorry, guys. Just a moment of panic. Let me just do it again. Okay. I wanted to show you the map, but instead it just jumped somewhere else. And I apologize for that. Let me just go back here. So I had little time to start with, now I have a bit less. Are we back to where we started? Can you see the slides? Yeah? Good.
Yes, you can, yes.
Thank you. So no map. Imagine a map of the world, 100 countries are covered. So there's a few countries, sub-Saharan Africa, and a few countries in Asia which are not covered. So how do we see this? Well, it's a standard role model of selection. There are two sectors, home and market. People differ in the skills and tastes for the two sectors. And we assume that these are independently distributed. We assume that people are paid according to their ability. This could be a standard bonus contract, or it could be just a career progression. So more able people are promoted more quickly and hence they earn more. Now, what we care about, like our job today, is to try and identify the sign of the difference between this beta 1 and this beta 0. Where beta 1 is the return to ability in the workplace, and beta 0 is the return to ability at home. You can imagine reasons for why, talented, well-educated women would have a high return at home if that allows them to match with an equally educated and wealthy husband. That might be a higher return. So it's not straightforward that the return is higher in the workplace. So intuitively, how do we go about identifying this? Well, if there is positive selection, these are the N, the taste for being at home, and A, the ability, okay? If selection is positive, the frontier that separates home and work is positively sloping, which means that people with high ability and low taste for being at home are more likely to be at work. Okay? So if you observe an increase in female labor force participation, so if you go from the dark purple to the light purple, the wage will go down. Because as you increase the female labor force participation, the average ability, you see it here, decreases, and hence the average wage decreases. Vice versa, if you have negative selection, that is, if the returns are higher at home, you get a negatively sloped frontier, and an increase in female labor force participation will attract more able and women who are both more able and have a stronger taste from being at home, and that will increase the wage. So that's the correlation that we're going to estimate in the data. Now, intuitively, is what I just said, if selection is positive, wage will go down as the labor force participation increases, and if the opposite is true, the selection will be negative. But most importantly for us, we are interested in establishing under which conditions having the wage going down when the labor force participation increases implies positive selection. Because one direction of causality is true from the model, the other direction depends. It depends on three conditions, which I'm going to put up here. I apologize for the algebra. If you don't want to look at the algebra, the intuition is quite clear. The difference, the first term is the difference between men and women when employed. And this is made of three things. It's made of the difference in fixed pay, the pay that doesn't depend on ability. It's made by the difference in selection, which is what changes when labor force participation changes. And the sign of that depends on the difference between the returns at home, beta 0, and in the market, beta 1. Now, in order for us to infer, so what we want to do is infer from the correlation between this and this, we want to infer the selection sign. So we need all the other terms not to mess things up too much. So the first assumption that we need is that the correlation between fixed pay and labor force participation is not larger and opposite in sign. Effectively, what that does is that it rules out that women are more discriminated in Sweden as opposed to India. So we need that the correlation is not stronger in places where the labor force participation is higher. So that's kind of straightforward. The second thing we need is that returns, so the assumption, the identifying assumption we use in cross-country variation, we need returns to be higher at home or at work, both in the same direction everywhere, right? That might not be the case, and so another form of identification that we use is that within country, we use variation in cohort, because cohorts that are born at different points in time face different labor force participation when joining the labor market. And the final thing that we need is that the selection of people in our firm reflect the selection in the labor force, because ultimately that's what we're relying on. So these rules out say that women are more discriminated, again, at the point of hiring in Sweden than in India. That's what we need for things not to get messed up. And also we need men not to have a job which is better, in a local job which is better than the job with a multinational. So I will show you evidence on these three conditions starting from the next page. Okay, so that graph, which went fast, just shows the correlation between the gender ratio in the firm on the vertical axis and the labor force participation in the country. So as you can see, these are very strongly related. So the gender ratio in the firm mirrors that in the country, which suggests that the gender ratio in the country binds for the firm. So the firm is not able to undo the constraint that the country imposes. So this is our reduced form test. We regress the wage of individual I in country C for age group A on labor force participation when people of that age group in that country joined the labor force, because that represents the norms that they were facing when deciding whether to work inside or outside the home. We'll have a female dummy with the coefficient gamma, and of interest, the interaction between the two. So our coefficient of interest here is beta, which, if negative, indicates positive selection, meaning as you have more women in, the average ability falls and hence the wage falls. And if positive, indicates positive selection. Okay. So normally at this point I ask whether this makes sense, but as there are no questions asked, I keep going and I'll show you the result. So the main result is that the data is consistent with positive selection. There is a negative relationship. This graph has the gender gap in pay in the firm on the horizontal axis and the labor force participation ratio, women to men, on the horizontal axis. And you see that the gap is actually positive, meaning women earn more for the same position, the same everything, in countries where the female labor force participation is very low. Like around 20%, we're talking India, Pakistan, Bangladesh is around 30%. And then as you go up in labor force participation, the gap goes down. And then it hits about the average level for the OECD in this sector, which is around minus 16%. So around here is minus 16%. Now, a couple of things. We needed the sign of the variation to be, the sign of the selection to be the same in all the units that we're using to identify. So one possibility is that selection is positive in some countries and selection is negative in others. So what we do is we use within country variation. So this is column 4. In column 4, we use within country variation. And in column 3, we use across country variation within cohort. And you see that the coefficient of interest, the beta, which is the last one here, is very, very similar. The other two columns are just, this is without any controls, and this is controlling for job type, so making the observations more equivalent. And again, makes very little difference for the estimates. And finally, the fifth column looks at new hires, in case the process of leaving the firm differs and contaminates the results. So this is only people in their first year. So what the firm pays when they first hire people, and it's exactly the same message. So a key question, a key assumption that we have here is that these differences are driven by the threshold, the bottom threshold, meaning that the bar is higher for women. And if that's the case, we should observe that the difference in pay comes entirely from the lowest quintiles. And that's what we see here. So there is hardly any difference at the highest quintile. So the best women and the best men are the same. But the last woman to be hired is much better, according to the firm, than the last man to be hired. And this is important because another interpretation of the data could be, of the averages, could be that maybe all the men in these countries, say India and Pakistan, work for the government. And that's why you're not observing the most able men. But from this, we see that that's not the case. Okay, so this is within and between country variation, which we see. This does the same thing. So what we do next is to actually take the model that I showed you earlier and actually estimate it with the data. Okay. So to do that, so why do we do that? Because that allows us to estimate counterfactuals. So we can say if the country were to equalize gender norms, then what will we observe in the firm? Who will be better off? Who will be worse off? How much will productivity increase by? So let me walk you through this. We assume that people differ in ability, but in the population, men and women are the same. Okay? They're all drawn from a normal 0, 1. For every gender, cohort, and country, we have the same distribution. Likewise, preferences for staying at home, they are equal in the population. Okay? Now, we have established that the sign of the selection is positive, so we set the returns to ability at home to 0. You can assume that they are positive, and then the interpretation of our data is the difference between the returns. That's the same. We just don't estimate that parameter. Then we assume that the firm wage policy is log linear in ability, so that people who are more able, who contribute more to the firm, either they're paid more through bonuses or they are given promotions more quickly. So the alpha 1 represents the average wage for a person of gender G who has been in the firm for T years, is of age cohort A, and is in country C. So we actually allow for country-specific difference in discrimination or difference in absolute advantage between men and women, which they could be. Beta 1 is the returns to ability. The reason why normally in macro data, you cannot disentangle these two, that is, you conflate the difference in ability with the difference in absolute advantage, because you only observe the mean. But here we observe people of the same estimated ability, same gender, same cohort, etc., and we observe variation in their pay. That's why we can identify differences in ability from average differences by gender separately. So that's the payoff for going to work. This is the payoff from staying at home. And the key parameter here is the alpha 0, which differs, which we will allow to differ, and then in the estimates will differ between men and women. Okay, so we interpret the gap between the value of staying at home for women and men, other things equal, as the cost of social norms, or equivalently as the tax that women have to pay when entering the labor force. Okay, so these are the these are the equations that we have. We have 3 equations and 4 unknowns. So we normalize, as is standard in the selection models, the variances of the 2 terms to sum to 1. So this is a better table to understand what's going on. So the LFP, the empirical target, the labor force participation, the difference allows us to estimate the average value of staying at home. The average log wage allows us to estimate the wage. And the variance, this is the important thing, allows us to estimate the returns to ability. So we have to restrict the sample. So we start with 100 countries. Some of them are very small, so there is not enough variation within cohort. So we have to restrict it to the 58 countries for which we have enough employees. We take as the wage the residuals of a regression of log pay on year and function dummies. Function means HR, finance, and the like. And then we use, as we already said, the labor force participation for gender G and cohort A in country C when that cohort made the decision whether to enter the market or not, so when they were 20. Once we calibrate our parameters, we can retrieve a measure of ability. And then we can compare the ability of men to the ability of women in the workforce. And it always goes one back, so it takes 1 step back and 2 forward. So that's our estimate of ability, okay? On the horizontal axis, you have the female labor force participation over the male labor force participation. And the 2 lines, the blue are the women and the orange are the men. So the calibrated ability in countries like India, remember the assumption is that this is distributed with standard deviation 1, has a gap which is about 0.7 standard deviation. That's in India. As you converge in labor force participation, this difference shrinks, but it never goes to 0 because there is no country in the world where there are more women working than men. Now, the parallel to the quantile regression that I showed you earlier is the difference in distribution that comes mostly from the left tail. So the orange are men again, and the blue are women. And now the three panels, this is the calibrated productivity. The three panels are split by levels of female labor force participation. You see that when that ratio is larger than 3/4, they're almost identical. And they come from the same tranche of the distribution. In the middle case, men are less able and more similar. And in countries where the labor force participation is below, the ratio is below 0.5, so where there is 2 men or more for every woman who works, you see that the ability of men is shifted all the way to the left, but the right tail coincide. So the best men and the best women are equally able, but then most men are of lower ability. Okay, so these are estimated out of the labor force participation and our assumption on the pay policy. So we only use wages to estimate these numbers. In order to validate them, we correlate them with other measures of productivity, which we have not used to estimate this. So we have data on appraisals. We have data on wage growth, so we can estimate ability from the first year when they join the firm, and then see how that correlates with the growth of wages thereafter. And we can correlate them with sales. Now, I don't dare hit these buttons because who knows what I've done, they might bring me to the wrong place. So trust me that these things are all positively correlated with our measure. This is the difference in the payoff from staying at home. It mirrors the difference in ability. But the interesting thing, which I might try to do, see? Oh yeah, okay, good. It correlates with standard measures of social norms. So these are the World Value Survey measures, like preschool child suffers when women work, when the mother works, or being a housewife is equally fulfilling, or when job are scarce, the men have priority, and so on. So we take all the World Value Survey questions that have to do with gender norms, and we correlate them with our measure of the tax. And you see that countries with a higher tax have more restrictive norms and vice versa. So one thing that is legitimate to ask is whether we can reconcile this, not by difference in ability, but rather by difference in preferences. Okay? So to cut a long story short, and I'm happy to discuss this when we have the Q&A, but I tell you roughly what we do. We back out the magnitude of the difference in preferences that we need to reconcile the results. And then we compare it to all the measure of preferences that we could find. And there is their order of magnitude difference. We will need an enormous difference in the preference from staying at home in order to explain the gaps that we find in the data. So, a couple of things which I really want to show. The first is this. I want to show you how our estimates that come from this one firm, a big firm, admittedly, but just one, they capture something which is relevant at the economy level. So what we've done to show this is we have used the balance sheet data from Orbis, and we actually have more countries than that. We're slowly putting them together. These are very big data. And what we do is that we correlate the productivity of these other firms with the measure of skill gap that we find in our firm. Okay? So this is a standard production function. You have log sales on the left, and you have labor, capital, controlling for GDP and labor force participation, because it's a cross country. And you see that the ability gap, which we estimate, is negatively correlated with the productivity of other firms in the economy. Now, there could be other non-observables at the country level that explain this. So another thing that we do, which I like, is to look at the sectors where the firm operates and only look at the difference in difference within countries. because of course the estimates based on one firm are more informative for the sectors, the same sectors where that firm operates. And that's this regression here. And there you find an elasticity to the talent gap, which is similar to the elasticity with capital. Now, different form of exercise, but perhaps more interesting, I think, is where we look at the average productivity by sector, now, not by firm, and at the dispersion by sector. The dispersion of productivity by sector is a measure of misallocation. A rough measure, but a measure of misallocation. And you see that in countries where our estimated ability gap is higher, we observe more dispersion in productivity across sectors. So that was the first thing that I wanted to show you. The second thing that I want to show you is how we simulate the difference, the cost of gender norms. So what we do here, because we have all the parameters of the firm, we assume how the firm responds to changes in the environment. We try many different models. And then we use that to see what if, the counterfactual, what if the tax went to zero? What if men and women faced exactly the same barriers in participating in the workplace? So the first thing that would happen is that the male labor force participation will go down and the female labor force participation will go up. The ability of the average employee would go up, mostly for men. Okay, so this is the man ability, a baseline. That would be the man's ability after equalizing female gender norms. And the average ability, which will be the same for men and women, because at this point there is no difference, will also go up. Now, how does this happen? It happens because the average ability of entrants, so the women who would enter now that the barriers has been lowered, is higher than the ability of the men who would exit. Now, notice this is still a matter of composition. Men and women are exactly the same ability. It's just the division between home and outside the home, which is different. And the bottom line, if you want to put a number on this, the firm did want a number, is that globally, the increase in productivity, keeping the wage bill fixed, would be of 32%. This, of course, is much higher in countries like India and Pakistan, where hardly any women work. It's much lower in countries like Eastern Europe. It's actually negative in Russia and Tanzania, which are the only two countries where there are more women than men at work. Okay. So then we do other counterfactuals, which I'm more than happy to discuss in the Q&A. And in particular, we look at the effect on welfare, because some people will gain and some people will lose out of this. And we also see what happens if we change labor regulation. So how easy it is to hire and fire people. This is actually interesting because normally labor regulation is seen as a protection of workers. In reality, because limiting the firm's ability to reward talent hurts women more than men, because women are generally more talented in the workplace, it actually ends up hurting women more than anything. So this is the gender norms. We can discuss it later. This is the ability, okay? That's the labor regulation. And, okay, sorry. Another thing which has disappeared from my slides is the bottom, the other thing that we can do is to correct the wage gap. Because the current wage gap that we measure doesn't take into account the difference in ability. Now that we know that the average woman in the workplace is more able, we can adjust the wage gap. And of course, you get larger wage gaps nearly everywhere. So, bottom line, what did the firm took from this when we discussed it with them what the main takeaway was, oh, but all our equality policy are not equal after all. Because what they always try to do is to promote the same number of women and men. It's a bit like when in committees you put the same number of women and men without accounting for the difference in composition and the difference in talent that you have in the labor force. So that was their take, that what looks like an equal policy is not equal if it's applied to people who are fundamentally different. And for us, I think the key thing is that the effect of regulation hurts the most talented. And the selection of women in the labor force is clearly positive. So Arthur Lewis was not surprisingly right that a better allocation of talent to increase national income is to find good employment for women out of the home. And I leave it at that because I would like to have a conversation. There is much more in the paper. I can go deeper in any of the aspects that I've showed you. And we can take questions and keep going.